IPSec is a very common cryptographic function that we use in today's business and personal lives, but how do the components work? Well, we're going to discuss that coming up next.
You're watching IT Pro TV.
Welcome back to Security Plus here at IT Pro TV. Today's episode all about that IPSec, and I know there are jokes just waiting to be happening right there, but we'll keep it adults for today, even though I'm having a hard time. Yeah, I know, but let Wes down. Wes, we need to understand how IPSec works so that we can answer questions based on that we might find in our Security Plus exam. Plus, it's probably a good idea as a security professional, since it is a common protocol, on how does this work. So where do we begin with IPSec?
All right, let's go ahead and let's do just a basic introduction of what IPSec is. And then we'll start doing like Dan said. We'll start pulling apart some of the components and the processes and let you know. And then hopefully by the end, we'll show you a little demonstration of what IPSec would look like if we were out there packet capturing, so you can see how it will actually benefit us should you choose to implement it. So let's get started. IPSec, that is short for Internet Protocol Security. It is really not just a single technology. It is actually a group of technologies, a group of protocols, all working together to secure your information as it goes over public networks. Now, you might be asking yourself, well, don't we really do that when we talk about things like HTTPS? Well, yeah, the answer is yes, but that is for specifically web communications, right? Imagine that you have two branch offices, all right, and you have a main office, right? You're not necessarily going to be communicating with HTTPS, right? You want to secure that communication as it goes across those public networks. So we do this in things like virtual private networks, right? And in some of the places you might see that is in, like, for instance, in branch office connectivity. So imagine you have a main office, you have a public network, which we usually call pretty much the internet, right? That branch office, we want to make secure connections to the resources from the branch office into the main office across that public network. We can use something like IPSec, all right? We can also do this in things like, for instance, partner extranets. So imagine that Dan has a company that supplies maybe components of things that my company builds, right? And we want to do some kind of communication so that I can expedite, buying those parts from his company. Well, we might do something where we have some kind of partner extranet. Now, it doesn't really change, the diagram here. It's just, what are you actually using it for? Now, these are typically what are known as site-to-site, router-to-router, gateway-to-gateway VPNs, and we don't necessarily have to use IPSec, but it is common to use IPSec in these type of VPN communications. How about this? How about a situation where maybe you have one user that needs to make connection across the public network into a remote access server and then gain access to the corporate resources or the resources within the corporate network, right? We can also do remote access VPNs as well. Now, the difference between those two type of VPN site-to-site means that the routers, the gateways, if you will, right, they're establishing what we're going to see here, that tunneled or encrypted communication. Here, with a remote access VPN, right, you'll notice that we do not have two routers here, right? It's not site-to-site. What we have is client software typically running on the operating system of the client that's going to connect, and they're going to connect into a gateway. So you might hear it called client to gateway or even just a remote access. But notice the difference here. Multiple connections can be used in these site-to-site type VPNs. A single connection from a remote access VPN into the corporate network here. So those are just some of the examples of where you can use this, where you can use IPSec, and again, remembering that we can secure the communications across that public network.
Yeah, I think you're probably hitting the nail right on the head, Wes, when it comes to where we see IPSec typically, which is within those VPN connections, right? Because it works great for that. It's been used historically for that, and probably will for a while until we come up with something even better, larger, faster, stronger. We have the technology, right? So eventually that's exactly what will happen. Until then, IPSec's doing a great job, but now we need to understand the components that are making up IPSec, because we might get a question or two about that.
Definitely.
On the old Security Plus exam, you know what I'm saying?
That's
so
right.
What's one of the first components we would need to know about?
All right, so how do we establish an IPSec communication is really one of the things that we want to work with here, and that's something known as security associations, right? Let's go ahead and take a look at what a security association is, all right? It sounds like it's fancy technical jargon, and it really is, but all it really boils down to is that our endpoints are going to establish trust relationships. That's what a security association is. It's really just a trust relationship between two endpoints, or in this case, you see the one on the bottom, a site type communication between the gateways themselves, and they are what are known as IPSec peers. So security associations essentially are that trust relationship that's established between these two IPSec peers that are going to make this communication between them. Now, the security associations come in two flavors, all right? I don't know why I'm hungry. I'm going to call them flavors, right? And the first one is what is known as a Phase 1 security association. You might also hear it called an IKE Phase 1 security association. Those are synonymous terms. They're the same thing.
What did Dwight D. Eisenhower have?
I know, right? So not that type of Ike, and I'm glad you pointed out. I'm glad you bring it up.
Good mnemonic, though.
It really is. It's a good way to remember
it. Yeah.
That's Internet Key Exchange. Oh. All right. And there's a version 1, version 2. You should be using version 2 today. It has a little bit more features than the earlier one, and it also requires less processing power. So kind of like you were saying, bigger, better, faster. Well, that's an example. He didn't even know, but IKE version 2 is typically the one that we're going to be using. Now, in a Phase 1 security association, this is really, it's also what's known as a main mode security association, and it's really for traffic management. All right, when we set up a Phase 1 security association, we're going to define a few parameters. When I say traffic management, here is a big exam alert. In a Phase 1 security association, there isn't any encrypted data. You know, we're not that data that we want to make sure it doesn't get into anybody's hands. We're not sending that yet, right? This is going to be a series of steps in which we are going to negotiate the parameters. And by the way, the negotiation is every one of the categories that's going to fall through this. So in the negotiation, we define all these steps that are coming, okay? And it's going to define what the key exchange method is going to be, right? We've talked about Diffie-Hellman. You're going to pick which Diffie-Hellman method. Is it going to be elliptical curve cryptology Diffie-Hellman? Is it going to be just Diffie-Hellman? Probably not. It's probably going to be some form of like ephemeral Diffie-Hellman with elliptic curve cryptology in it as well. We're going to define the authentication. All right. Now, the authentication comes in a couple of forms. It can either be a PSK. We've talked about those, a pre-shared key. I could set a password up, and share that password with Dan, and we could use that as a way to do the negotiation, the authentication. Dan knows the password. I know the password. Well, guess what? It's got to be him unless the password is stolen. And that's why the other option is, and used a lot, especially when it comes to gateway, is the other option for authentication, and that's certificates. Again, remember, passwords, passphrases aren't quite as secure as a certificate. So if you're going to go through the process of setting up an IPSec VPN, chances are you're going to be using a certificate. But understand that you could use a pre-shared key as well. Next thing that we're going to do, and I did want to just remind you of something that we mentioned earlier. Remember the Diffie-Hellman key exchange? The higher the group number, the stronger it is. But then we're also going to define what the encryption is. And the encryption could be one of 3 protocols, right? It could be DES, which probably not going to use DES, triple DES, or it could be AES, all right? And then last but not least, we're going to define the session duration. One of the things that IPSec does is it allows us to provide confidentiality, integrity through the authentication, because we can use hashing algorithms. It also defines non-repudiation, and it provides anti-replay protection, or it provides replay protection, I should say. And that's because part of the session duration is defined before we start communicating, and when that session is done, IPSec will tear the tunnel down. All right, and if I capture information, I try to replay it to Dan when he's had an IPSec communication, let's say between him and an endpoint, the problem is that session is tore down. That's not going to be trusted. So we also do session duration. That is the Phase 1 security association, but at this point, it is just defining traffic management to set up the second phase. All right, Phase 2 security associations, wait for it, IKE Phase 2, they're also called.
Very creative.
It is,
yes.
You know, it really is. They didn't ask me.
They went with that.
Yes, absolutely. And they didn't ask me on that one.
No,
this is also what's known as Quick Mode, a Quick Mode security association. And now here is where we're getting into data exchange. Now, Interestingly enough, we're going to go through that same process. Now, a couple of steps are a little bit different here, and you'll see what I mean in here in a second, right? So we set up 2 one-way tunnels, all right? 2 one-way security associations. And what I mean by that is in phase 2, I set up a phase 2 security association to Dan's computer, and I'm going to use that to pass him encrypted information. He's going to set up a one-way phase 2 security association to me, and he's going to use that to send me encrypted information.
So does that mean that this phase 2 is going to look a lot similar or very much like phase 1, just coming the opposite way?
It's going to be 2 of them.
Oh,
yeah,
well, you're
there's
right.
2,
But I mean,
yeah.
we've set one up, you said, and now we've got to go the other way, right?
No, that's a completely separate thing.
Oh.
Yeah, absolutely. Phase 2 are completely separate than the phase 1, right?
Okay.
And because in phase 2, look what all this stuff that we go through. We go through negotiation. And by the way, we're going to negotiate all this stuff that's below it too. This is all defined in that negotiation process. We're going to define what is the IPSec protocol we're going to use, which means do we need the authentication and integrity without encryption, or do we need authentication integrity with encryption? And those 2 protocols that we choose will either be something that we're going to look at, AH or ESP. Then once that's done, we're going to define what the encapsulation method is, and we'll talk about the difference between tunnel mode and transport mode coming up. And then authentication. Authentication this time is going to be MD5 or going to be SHA. And then there's also session duration for the main mode. Or excuse me, the quick mode security associations too, because we want to know once that data is exchanged, how long do we keep this open for? How long should Dan wait for another packet to come? How long should I wait? We're going to define that before we actually set these up so that once that data communication is done, that security association is torn down. Then last but not least, there's an optional DH exchange, Diffie-Hellman exchange, and this is for things for if you want to implement perfect forward secrecy. And what that means is that it's going to rotate through keys for each communication that goes through that tunnel. It's optional. It doesn't have to be implemented, but that's one of the ways that they can implement perfect forward secrecy. I don't know why I can't say. I always want to say forward perfect secrecy, but it is perfect forward secrecy. So those are actually the 2 security associations, phase 1 and phase 2. Remember, phase 1, traffic management, we don't send information that the data that we're going to encrypt, right? The actual data that we want to communicate. That is one phase 1 security association. When we set up phase 2 security associations, those are 2 separate from phase 1, and I'm glad you asked that, Dan, and they're 2 one-way security associations. One for me, let's say going back to Dan, and one from Dan's computer back to me that will actually do the data exchange at that point.
All right, so Wes, now you mentioned back up in our previous slides, you were talking about the IPSec protocols. Are those specific protocols that we need to be aware of, and if so, what would they be?
Definitely. So the first answer to that is yes, you absolutely. They are the major components within IPSec. All right, and that is really depending upon if you want the authentication, you want the integrity, but you don't want encryption, or do you want encryption? And we'll talk about the first one here. The first one here is called, no, just kidding. It's AH, and that is short for authentication header. And authentication header provides the authentication. Imagine that, it's in the name. But it also provides the integrity of the information. The one thing to keep in mind is that not only it provides the integrity, but the one thing that it doesn't do is it doesn't provide encryption. All right, so if we want to use encryption, we'll use the next protocol. Now, I also want you to know an IP protocol identifier that it uses, and just be aware of this on the exam, that it uses IP protocol 51 to identify that it is using AH. That's a little important thing to remember, but remember, we only get the authentication and the integrity with AH. The authentication, I can prove I am who I say I am because we entered into this security association before we even started sending information. The integrity, remember, we're using things like MD5 or SHA to verify each packet that comes across that security association is in the state that we expect it to be in. The problem is it doesn't encrypt. And that is something, when it comes to encryption, we call ESP. Now, ESP is not this, hey, what are the lottery numbers for tomorrow? This is what's known as the encapsulating security payload. All right, this provides us the authentication, just like AH does. It provides us the integrity, but it also gives us the encryption. This is what is actually going to encrypt that information as it makes its way again across that IPsec tunnel. So be aware that we are verifying and validating the file integrity, but as you can see here, we're also going to encrypt the information too. I also want you to be aware that this has an IP protocol identifier of 50. Just be aware of that on the exam if they ask you that, between the two different ones. Why they did AH as 51 and ESP as 50, again, they didn't consult me. These are brains a lot smarter than mine, but it is a way that they identify that you're using ESP inside of your IPsec communications.
All right. Well, that's good to know, right? We got that squared away. You also mentioned a couple of encapsulations that we need to be aware of when it comes to IPsec. Tell us a little more about that.
Sure. So we've got a couple of methods here, right? So let's talk about the first one up here. The first one is transport mode, and the transport mode is commonly used between clients and like a workstation and a server, all right? So look at the very first packet, right? Without IPsec, we've got the IP header, which is your IP addressing information. We've got the TCP UDP, right? That's our back to our OSI model, right? And then we've got the payload. In transport mode, what happens, and I just gave an example of ESP in transport mode. If you want to change these to AH, it would be AH in transport mode. Or you can use AH and ESP, and then you'd have two of those little packet headers in between. So ESP transport mode, notice what happens, right? The original header, the original IP header is still there, right? But the payload is encrypted. Now, in tunnel mode, this is where we talk about those site-to-site VPNs. Notice the difference here, all right? Remember the original header in transport mode, that's out there for use for routing purposes, right? In a site-to-site type VPN where we have tunnel mode, the entire packet is encrypted. Notice everything, right? I could basically, if I wanted from ESP to ESP, I could just block this out so you couldn't see it. You wouldn't know what the original header is. You wouldn't know any of that. And then it attaches a new header out in front. So note the difference between the transport mode and the tunnel mode. These are the encapsulation mechanisms that it uses. Transport mode, client to server, workstation to gateway, if you will. Tunnel mode, which is typically the default, is commonly used in those gateway to gateway or router-based situations.
All right, that's actually very clarifying. Thank you so much for helping us understand the two different types and why we would use one versus the other, giving us a lot of really good information behind IPsec and how that's working, because that's what's important about today's episode, is figuring out those components and where they're supposed to work. But that's not all. Right? If you act now, Wes is actually going to show us a little bit of how, give us a bit of a demonstration of how IPsec might be utilized.
Yes, absolutely. So I'm on a Windows 10 machine here, and I actually have an L2TP. I'm going to mention this just for now. You're going to see more of this when we talk about other like tunneling protocols. And IPsec, if you want to use it as a tunneling encryption method, you have to use it with what's known as L2TP, Layer 2 Tunneling Protocol. You can't use it with the earlier outdated point-to-point tunneling protocol. So I just want to throw that out there as a little exam thing. So when I say this, you understand what I mean. I've set up an L2TP IPsec tunnel here. And I've got Wireshark running here, and let's go ahead and we're going to start a little bit of a packet capture, and I can't remember if you, oh, that's the magnifier. There, you can't think of a way, is this it? Yeah, there we go. So you can see it a little bit easier. What I'm going to do is I'm actually going to run a ping to the server. So 192.168.1 or 0.150, and we've got some communication that's going on here. And I'm going to go down to my network connection, bring up our network connections here, and in here there is VPN. Notice on the left-hand side we have VPN. Notice that we have a VPN set up already. Now, I'm going to go ahead and connect to this. Now, when I connect to this, know that it says actions needed. We're going to sign in, right? And I'm going to go ahead and use my username and password here. And that was VPN user 1. And then our super secret Microsoft password will connect. And let's see here. Doesn't look like I was holding my mouth right. I'll try that one more time. Oh, interesting.
It's the other password.
Oh, no. I know what it is. It's trying. I have to let it know that, hey, you need to do this on. I got to tell it the server.
Yes.
This server isn't domain joined, so it's like I don't know who that is. Let me try that again with the actual server's name, VPN user 1. And then let's try the password again and see if that, I bet you that'll work. There we go. So it connected. All right, so we have an L2TP connection with IPSec. And what I'm going to do here is I'm going to rerun this ping. In fact, let me just hit the up arrow. And I'm going to rerun this ping. And I'm going to stop it. I want to show you something that I think is kind of cool here. And we're going to go back to our packet capture. All right. And what I'd like you to see, let me see if I can find ICMP. All right, so here was the pings in an unencrypted method, right, before we set up the tunnel. All right, and what you're going to notice here is if I take this out, those last 4 pings that I pushed over the tunnel are all encrypted. It all says ESP. I can't tell. You guys could see. You were privy to the conversation. You could see that it was a ping packet, right? A ping packet's out there in the wild. It's not encrypted. IPSec, it's going through the tunnel. It's going through that IPSec tunnel, and it doesn't matter if it's an ICMP echo request. You're not going to see what's in there, all right? And we can see that it's using encapsulating security payload. A couple of things here, just real quick, as we round out our discussion here. You'll see this ESP SPI. SPI, it's fancy term for, this is a security parameter index. What does that mean? It just associates it with the security association that we just created. That's the number of the security association. That's how, one of the ways that it protects against replay attacks. All right, Dan's communicating with that server and I scrape this packet off and I replay it later. This security association is already predefined when the tunnel is going to be basically taken down. Computer's going to look at that and say, garbage, and throw it away. Sequencing, again, much like we talk about TCP, Transmission Control Protocol, doing sequencing and rearranging the data, we want to make sure that we know what the next packet is. And this is kind of cool, Dan. Check this out. So we see the sequence 16 right here. Watch how it increments. 17, 18, 19, 20, so on and so forth. If in that sequencing it went 1922, my computer would discard that packet and call back, much like TCP would in our OSI model, and say, Dan, I was expecting 20. I got 22. Can you resend the next one in the line? So again, you can kind of see how it's working, and I believe this stuff is really, really, really cool. I really like it. There is there we go, ISACAP, right? Remember we talked about the key exchange? This is how IKE happens, all right, with something known as the Internet Security Association Key Management Protocol. Boy, that's a mouthful. ISACAP, right? It is the protocol that allows us to do that IKE key exchange across that public network. Hopefully this has helped you out to understand what the components are, how it's implemented, and what it looks like when it is.
Yeah, it's a great deep dive into IPSec, and pulling back the covers on this kind of thing can really help solidify these concepts that you're trying to learn about these very, how do I put it, esoteric type of protocols that you might run into from day to day, and help really give it some wheels and tangibility for you to latch on a little bit better. So great demonstration. We appreciate Wes on that. That being said, we're out of time for this episode, but there is still more to come in the Security Plus series. So join us then. Until then, have a great day.
Thank you for watching IT Pro TV.